In this video, I will show you how to use the law of cosines to solve this multi-step word problem. You'll find that the actual solution is not that tough. The hardest thing is being able to understand what they're trying to show you in this picture. So I'll try to help you out with that. A reconnaissance plane patrolling at 5,000 feet sights a submarine at a bearing of 35 degrees. Bearing of 35 degrees simply means it's 35 degrees away from north. So it's just what they're showing you in the picture. At an angle of depression of 25 degrees. So the submarine, angle of depression, 25 degrees. A carrier at a bearing of 105 degrees. So again, that's if this is north, bearing 105 means 105 degrees away from north, like that. And at an angle of depression of 60 degrees that you can see right here, all right, 60-degree angle of depression. How far from the submarine is the carrier? So our ultimate goal is to find Z, the distance between the carrier and the submarine. Well, guess what? First we're going to find X, then we're going to find Y, and then we're going to find Z. So this is a multi-step problem. The good news is to find X, we have a right triangle happening here. So we're not going to use the law of sines or law of cosines. We're just going to use good old-fashioned trigonometry. So I want you to focus your eyes on the triangle that I'm about to trace for you. Okay, this is a right triangle, even though it's drawn kind of in 3D, so it's not going to necessarily look like a right triangle. All right, this is the triangle that we are going to solve first. So understand that the height of the plane is 5,000 feet. So this vertical line right here is 5,000. Also, you need to know that we have this angle right here that I'm marking. And that's because they gave us the angle of depression is 60 degrees. But the angle of depression from the perspective of the plane and the angle of elevation from the perspective of the carrier, those are always the same. They are alternate interior angles. So whenever you have an angle of depression, the angle of elevation will be exactly the same because of alternate interior angles. So this angle that I just marked is 60 degrees. So I'm just going to put a little 60 right here, nearby with maybe an arrow. Look, that's 60 degrees. So let's go ahead and solve this triangle. Okay, remember X is the length, right? It's not the angle. X is this length right here. We should be able to use good old tangent function. Think about it. The tangent of this 60-degree angle, tangent is opposite over adjacent. So that's going to be 5,000 over X. When the variable is in the denominator, you can swap these. So that will give us X is equal to 5,000 over tangent 60. So let's put that in the calculator and see what we get. Okay, 2,886.75. Okay, and we are talking about feet. 2,886.75. Let me double check. Okay, great. So we found X. Now let's find Y. Let me trace that out for you. So to find Y, we are going to focus our eyes on this purple triangle, which involves Y. Again, please understand that we have a right triangle right here, All right, even if though it doesn't look like a right triangle because this is drawn in 3 dimensions, you know, the plane is straight 5,000 feet straight up. So this is perpendicular. It is a right angle. So this is going to be very similar to what we just did. Again, because the angle of depression up here in the sky is 25 degrees, that means the angle of elevation from the perspective of the submarine is also 25 degrees. All right, the angle of depression and the angle of elevation are going to be the same thing. So let's see. We're going to do tangent again. So let's do the tangent of 25 degrees is equal to opposite over adjacent. So again, that will be 5,000 over y. And we will swap these. So we will have y equals 5,000 over the tangent of 25. So that comes out to be 10,722.53 feet. Now we have x and we have y, so it's time to find z, which is what we were really looking for all along. Be careful because this triangle down here at the bottom is not a right triangle. We know this because they told us that the bearing of the submarine was 35 degrees. In other words, if you measure from due north, the submarine is 35 degrees away from that. On the other hand, the carrier has a bearing of 105 degrees. So the angle between the two is going to be the difference between those two numbers. So down here on the water, the angle between the carrier and the submarine is going to be 70 degrees, all right? It's 105 degrees minus the 35 degrees. So notice that we have a side angle side situation. And when you have side angle side, you can solve it using the law of cosines. So that's how we're going to find z. Since we're looking for z, we're going to begin the law of cosines with z squared. So we're going to have z squared is equal to x squared plus y squared. Looks a lot like the Pythagorean theorem. But then we do minus 2xy cosine of angle z. So let's substitute in what we know. So we're going to have z squared is equal to, well, x is 2,886. So we have 2,886.75. So that's going to be squared. And then y is 10,722. So we have 10,722.53. And that's going to be squared. Minus 2 times x times y. So that's 2,886.75 times 10722.53. And then finally, we have the cosine of angle z. Angle z is the angle across from side z. So that's cosine of 70. And in the end, we need to take the square root of both sides. So what goes in the calculator will be the square root of all of this. All right, I'm going to spare you from watching me type this into a calculator, so I'm just going to do that off camera. So I'm getting 10,105.88 feet. That will be the distance between the carrier and the submarine.